Now we're moving into the particle nature of our light. So with our wave nature, it kind of is continuous, it acts like a wave. But with a particle, it's not going to be a continuous stream. So think about like a wave as a continuous stream of light or of water, if we're thinking about it like in the ocean. But for us, with a particle, we're going to start thinking about it in terms of energy. And how does that particle have different types of energy or levels of energy? So what I want you to think about is that energy is going to be emitted in whole number multiples. So I want you to think about energy in the sense of a staircase. So our light, our energy, is going to be like a staircase. So whenever you think about a staircase, you're on this step, and then you can take this step, and then you could go to this step, and you can keep going up. If you're really adventurous, you could go from this step to this step, and then you can also go down, okay? We know how a staircase works, right? But you can't hover at half a step. You're either on this step or this step. So if we thought about energy levels as being the steps, you have to be at certain levels of energy. You're either here or here. So think about this, if this was 10 and this was 15. You're either at 10 or you're at 15. You can't be hovering in between. So you're either on this step or you're the next step. So when I talk about light in the sense of energy, it's going to be talking, or as a particle in terms of energy, we're going to be talking about what energy it can have. Okay? So it can't just have a tenuous stream of energy values or possibilities. It can only have certain levels of energy. So I want you to think of each one of these steps as a level. Okay? So our energy is always emitted in whole number multiples. So that's what I mean. It's here, then it's here, then it's here. So level 1, then 2, then 3, then 4, etc. Can't be here or can't be here. Okay? Those whole number multiples, those levels, are called our quantums. Okay? So a quantum is going to be the smallest quantity of energy that can be emitted or absorbed in the form of electromagnetic radiation. Okay? So when we're talking about emitted versus absorbed, if I'm emitting, if I'm releasing energy, then I'm going to go down, okay? And if I'm absorbing energy, then I'm gaining energy, and I'm going to go up, okay? So that's just the difference between emission and absorption. And we're going to talk about emission and absorption in a couple of slides later in this chapter, okay? So quantum is the smallest, so the quantum would be the lowest energy level. So this would be 1 quantum. Then it would be 2 quantums. 3 quantums, 4, 5, 6, 7. So a quantum is what this is at. Now, what this quantum level is depends on the element, depends on the particle that I'm talking about. Everything's going to have a different level of quantums, okay? Now, you might be saying, okay, so it emits and it absorbs energy and all this, like, how do we know this exists? So before we dive too deep down into this, I want to give you an everyday worldwide example of how we've seen this absorption and emission of these quantums in everyday life. So one thing that you've experienced is black body radiation. So what is black body radiation? So this is when a solid is heated. So I heat up a solid and it emits electromagnetic radiation. So what I want you to think about is I want you to think about going into your kitchen. So say you go into the kitchen and you have your stove. So the tops of the stoves, the little heating mantles, are black initially. But when you turn them on, they turn on red. And so you might be saying, well, why is it turning on red? Well, it's heating up, and so it's absorbing energy, and then when it gets to a certain level, then it's going to release a particle of light, and then it's going to go down in energy. And when it goes down, when it releases that energy that's being released is going to go to a certain color. So when you're looking at the stove, you see it being red, because the stove is going to gain energy, and then when it releases that energy, we see it in the color of red, because remember, our wavelength is going to associate with our color. So when our solid is heated, it emits electromagnetic radiation. So I want you to think about those stoves that you've been seeing in your kitchen and all that. So let's talk about a few more definitions, and then we're going to kind of put this together. So we've already talked a little bit about particles and those kind of things, but I specifically want to define what a photon is. Okay? Whoops. So I specifically want to define what a photon is. So for us, a photon is going to be a beam of light. So a beam of light is simply a stream of particles called photons. So if you're hearing the word photon, photon is just a fancy specific word for the particles that are made up in light. So right now we're talking about its particle nature and its wave nature, these particles that make up light, these photons. Now, how are we able to figure out any of this? Okay? And so the way that we're able to figure out that light acts like a wave and it acts like a particle, and that it's going to be emitted and it's going to be absorbed, and all this is from what we call the photoelectric effect. And so they were able to do an experiment. So out here I've got my voltage, I've got my current meter, and I've got a metal surface. And so what happens is I just have light, the light shine on my metal surface, heats it up, and then it's going to cause an electron to be emitted. Okay? So let's write that out. So the photoelectric effect is a phenomenon in which electrons are ejected from the surface of a metal exposed to light of at least a certain minimum frequency. So it's got to be at a certain level. So think about the quantums. It has to be at a certain level of energy, at least one quantum for this to work. So the light is going to shine in at least at one quantum. It's going to hit my metal surface here, and it's going to cause an electron to be emitted. But it has to be at a certain low frequency or low energy. Okay? So what would that minimum frequency be? That minimum frequency is called my threshold frequency. So my threshold frequency is the minimum frequency for my electron to be ejected. Now, I was talking about when we were doing our steps, these are energy levels. Okay, so we have to have a certain number, a certain amount of energy here, one quantum. But here we're talking about frequency. So there's got to be a relationship between energy and frequency. And so on the next slide, we're going to talk about our second equation in this chapter, and that's going to be our particle or our energy equation. And that's going to tell me how does my frequency relate to my energy. So if I have to have a minimum energy, my lowest quantum, and now I have to have a minimum frequency, well, what is that for me to be able to eject an electron from my metal? All right, so we'll start on that slide in the next video.